So you are in the session here, bringing a cannon to a knife fight, deciphering China's offensive cyber weapon. And I encourage you to make sure your cell phones are on vibrate because those distractions are never appreciated. So without further ado, we'll pass the stage. Welcome these guys. Sorry.
Cool. Thanks, Brian. First off, thanks for having us here. We really appreciate the opportunity to talk about this. This is something that Johannes and I were very interested in from the beginning when the Great Cannon first made its appearance, and it was really unique. We just kind of we're coming at it from two completely different angles. So my name is Adam Cozy. I'm a security researcher with CrowdStrike, and I've been a China hand for several years. And
I'm Johannes Gilger. I'm actually from Germany, as you might be able to tell. And I'm doing something quite different from Cozy, but still we decided to do this presentation together.
Yeah, what was really cool about it is I came at it from the China aspect, and he came at it from a very technical aspect, and we met in the middle and just had piles of research, basically. So we're here with CrowdStrike. That's our company, but this is a little bit different than probably what some of you guys are used to with our tigers and bears, oh my, sort of thing. So this is a little bit different. So today, first off, we're just going to run you through, those of you that aren't familiar with the Great Cannon itself, we're going to run you through what happened, kind of a timeline of events leading up to it. We're also going to talk about the Great Firewall a little bit. That's going to be important because it's really hard to understand kind of the background of the Great Cannon without getting into the Great Firewall because it's hosted on a lot of the same infrastructure. Then we're going to go ahead and talk about kind of cleanup, what you can do to protect yourself, countermeasures, all these different things, and possibly a little bit on attribution, who is actually running this thing. So before we get going here, normal disclaimers, you guys can read that one, but no, I'll go ahead and read it off for our Chinese friends in the audience. 在我研究以前，要先和在座的中国朋友说一下，我的演讲内容是一个学术讨论的课题，没有政治目的或恶意。我们明白中国和西方有很多的不一样的地方，也尊重中国的信息工程能力，但是在国外实行审查制度开了个协防，totally messed that up，协防的先例。So yeah，对不起，我知道我的发言。So that's basically just to say that this is not meant to be a China bashing presentation. This is like we conducted this as purely academic research, but it is pretty clear that China was behind this, and so we're going to be talking a little bit about that. And as the audience, what we want you to understand is that China views this completely differently than the West, and so we're hoping to kind of impart that on you, that from their perspective, it's very different. Let's get into the Great Cannon. A lot of inside jokes while we were researching, but pretty much all of them ended with, that's what she said.
All right, let's start off with what actually happened for those of you who are not familiar with the Great Cannon. So on March 19 of this year, there's a website called Great Fire, and they posted on their blog that they've become under DDoS attack. It was 2.6 billion HTTP requests per hour. And to put that into some context, that would have meant that their hosting cost with Amazon CloudFront would have shot up, or they did shoot up to $30,000 a day, which obviously is not something that a website like this can handle. About a week later, GitHub on its status blog posted on March 26 that they've identified a DDoS attack and they're mitigating it. And what follows is like 5 days of permanent status updates as they tried to update their countermeasures to counter the attack, as the attack seemed to be evolving and increasing in volume. And around the same time, there were quite a few postings on Chinese language forums and boards where people complained that they would go to completely harmless websites, like big websites like Sina.com or Wuyun, and they would get this JavaScript alert. And you could see that the content of this JavaScript alert is the same on both pages, although they are completely unrelated. And then on March 31st, the attack on GitHub actually stopped. So let's talk about GreatFire. What does it do? GreatFire is a website which does censorship monitoring in terms of the Great Firewall of China. So what they track is the kind of websites that are being blocked by China and also the kind of keywords that are being blocked. So you can imagine like a search keyword or a combination of search keywords which would lead to the connection being dropped. So that's one thing they do. The other thing is that they also host and develop and spread censorship circumvention tools on their website. Okay, so pretty obvious why GreatFire might not be the most popular website to the Chinese administration, but what does it have to do with GitHub, right? So GreatFire actually uses a concept which is called collateral freedom, which basically means that they host their stuff somewhere that would be prohibitive in terms of economic costs for the Chinese government to block. So they actually have repositories on GitHub where they have this website on the left, kind of website, that's a GitHub repository, and it includes these tools like Android apps to circumvent the Great Firewall and guides and stuff like that, but it also includes Western newspapers, Chinese editions of Western newspapers like the New York Times or the BBC, and these actually live on the GitHub wiki pages. So they get updated daily on the GitHub pages. And the idea is because GitHub obviously uses HTTPS, the Great Firewall cannot distinguish traffic that's going to GitHub, whether it's going to one of these repositories or to any of the other repositories they don't care about. So the only way they'd be able to block that content would be to block GitHub off completely. And that's not something they can do out of economic reasons. The same is true, obviously, for CloudFront and other cloud providers. So to put that into context, kind of the timeline of the more offensive activities of the Chinese censorship apparatus, we're starting out on January 2013, when the Chinese government actually blocked GitHub for about 5 days. So they blocked it outright because that's the only thing they really can do. And there was a huge backlash against that because people basically told them, we cannot work without access to GitHub. And so they had to revert that and made it available again. And as a result of that, people actually started collecting lists of people who were responsible for creating the Great Firewall. Again, they created this list on GitHub. Then you can see a number of TLS man-in-the-middle attacks against popular services. Some of them were limited to the Chinese Research Network, the CERNet, but all of them used like self-signed certificates. So it was very obvious that they did some HTTPS man-in-the-middle, and not many people actually fell for that. Also, there was a DDoS attack against the Hong Kong Popular Vote website, where they had this kind of referendum going on, and they had set up the website to poll people in advance of the actual referendum to kind of get an idea what people are actually really wanting to vote for. And that was also DDoS attack. And once again, this was hosted on cloud infrastructure, Cloudflare in this case, and they were able to kind of mitigate the attack. So all of that leads up to the Great Cannon attacks in March of this year. And one might see these as isolated incidents or people testing some technology inside of China, but we think of that as more of a progression towards an ultimate goal, which is the Chinese call cyber sovereignty. And they realized that they have to have something like a Great Cannon because the approaches they tried before to block sites like GitHub didn't really work. Okay.
Okay. Everyone's laughing about the South Park thing right away. We have to get into the Great Firewall just a little bit because to fully understand how it came about is really important to understand the progression that led to the Great Cannon, and basically the reason, well, like Johannes was talking about, that this was a series of events that used some of the similar infrastructure to the Great Firewall and then progressed it even further to make it a more kind of offensive weapon. So of course it takes its name from the Great Wall of China, which fittingly was used to keep out invaders. And yeah, so that was gifted basically by the Chinese netizens at the time, What we think of with the Great Firewall is actually an amalgamation of many, many projects, thousands of hours of research in different projects. This kind of started basically, so in 1987, China sent its first email, which fittingly stated, across the Great Wall, we can reach every corner of the world. Slightly ironic, I don't think we realized how literal they were talking when they said that. After that, the internet was slowly coming into China, but what you have to understand is it didn't happen as organically as it did in Western societies. So the internet was a little bit slower to catch on in China and be commercialized, but it was very, very well planned. And they did this by actually structuring it so that all of the main international traffic would come in through different points. So in the beginning, most of the actual backbone of the Chinese internet was, of course, military and academic use. So we have the Chinese academic net, which the Chinese Academy of Sciences, Tsinghua University, and Peking University all used. And then the more commercial ChinaNet, which was run by China Telecom. Then in 1997, as this was coming on, the Chinese government wanted a way to kind of start keeping track of internet users and how the commercialization of the internet was going to affect the Chinese economy. They created CNNIC, which is the National Information Center, which basically started conducting all types of research on how to, basically how to monitor all of the people in China and what they were using the internet for. And one of their first studies actually found that most of the users in China were 18 to 24 and didn't have more than a high school education level and were saying some kind of revolutionary things. And so that was one of the very first reports that CNNIC put out. And so that was something that was of huge interest to the Communist Party, saying, okay, like there's the potential for anyone to basically put their ideas out there. Liu Wei, who's actually the current cyber czar of China, made kind of a reference in December at a conference I was at that basically was, comparing it to the YouTube comments and saying that like people were just posting just random, kind of stuff that wasn't in line with what the Communist Party was looking to have on the internet. So then in April 1999, there was a giant Falun Gong demonstration. It's a spiritual movement that has since been outlawed in China. But in April, they basically gathered around Zhongnanhai, which is the kind of their parliamentary building, and 10,000 people just came and just sat down. And that was a little bit shocking for the Communist Party. They probably had some flashbacks to Tiananmen and being like, wow, yeah, there are a lot of people that could rise up at any time. And the other thing was that the Falun Gong had actually been fairly early adopters of using the internet to kind of organize their meetups, show the movements, and kind of preach the philosophy that they were talking about online. So they were early online adopters, and as a result, that was something that stuck out in the Communist Party's mind. So in June 1999, they created something called the Center, which we're going to talk about a little bit more. First, a quick word on the Golden Shield project. If you go to Wikipedia right now and you look up the Great Firewall, you're going to be left with the impression that it's just the Golden Shield project. That's only partly true. So like I said, what we think of as the Great Firewall is this amalgamation of many projects, and the Golden Shield is kind of part of it. It focuses more on security. This is run by the Ministry of Public Security and is more designed to do surveillance and have an ability to where if they see people posting stuff that they don't like, actually track them down and arrest them or shut their internet off. Whereas the Great Firewall was much cheaper, they had better researchers, and it was really designed to be more of a censorship tool only. And so it's bottlenecking all the traffic. There's kind of a zoomed out view of the Chinese internet. So as I mentioned, those early 3 national level nodes, you can see up there, it's basically the kind of blue triangle between Beijing, Shanghai, and Guangzhou. So pretty much all of the international traffic was being funneled through there, which, like I said, it was very planned out to make sure that that's how they could control all the traffic. All of it's coming into there. So the Center, it's got a big long name, which you guys can read. If I say that every time, it's going to take a while. So we just refer to it as the Center. Lovely looking building. So when it was created, there's not a whole lot of public information about the center. Those of you who read the Citizen Lab report, which actually named the Great Cannon, got to give props to them. They did a fantastic job with that report and detailing it. But they mentioned just very briefly in there the center and talk about how there's not a ton of public information, and we found basically the same thing. So started doing some more research, and part of the reason is because it's actually co-located with CNCERT, but CNCERT wasn't actually created in 2001, which should give you some idea of the importance that they placed on the center. They immediately afforded it a lot of powers to go and do research and start working on sort of a web content filtering censorship tool that would basically become the precursor to the Great Firewall. And so the fact that they actually created that part first before they were even worried about any offensive attacks, which is normally what CNCERT as your emergency readiness team is going to respond to, national level incidents and stuff like that. So the fact that they were really prepping to have the censorship tool up and running before that is, kind of shows where their priorities were. So throughout the history of the center, there were all these multiple science and technology awards that were given out. If you look at some of their patents and the researchers that were part of the center and their patents, they all had to do with web content filtering on a massive, massive scale. So it's pretty clear what the center was up to at that point. One of the bigger things that they did was Project 005, which was specifically web content filtering, and that actually won the state award for 2002. And like I said, not a whole lot of information on that, but the more we kind of researched it, the more we realized that that was definitely a big part of it. And the other report that I recommend reading besides Citizen Labs is Mark Stokes from Project 2049 just recently did a paper on some of the military Chinese cyber operations outside of Shanghai. And one of the things that he talks about in there is the 005 Center, which is absolutely connected to this and to the Great Firewall and works closely with the military. So the center is still active today. One of the people that you're going to see when you look at the history of the Great Firewall is usually Fang Binxing. He's credited as being kind of the father of the Great Firewall, but you have to remember that there were hundreds and hundreds of researchers with this, and so he's just one of many. He basically started off as a professor at Harbin Institute of Technology, and a lot of his research was based around massive scale filtering. And then he kind of rapidly rose through the ranks very quickly. He ended up becoming director of the center, and even in 2008 was elected to the National People's Congress, which is their highest legislative body. So for somebody that was just kind of doing professorial research, within a very, very short period of time, he was kind of afforded all these special allowances and named an outstanding individual. And basically had come out and said in many public interviews that he was involved in the creation of the Great Firewall. As a result, he received quite a bit of hate from Chinese netizens, as you can imagine, has had shoes and eggs thrown at him, as well as had to famously take his social media account down after creating one in a record like 2 days after receiving like 20,000 hate messages. So that's got to be some type of record. So he is still, he's no longer head of the university or the center. He's retired, but still conducting a lot of research and is on several high-level meetings that are, councils that basically decide internet governance for China. A couple of the other ones, we'll just run through these real quick. Yun Xiaochun, the reason that he is interesting is because he was involved quite a bit on Project 005. And won the award for that. And now he is currently the director for the center. We believe that he took over management of it after Fang Binxing, and that is even as recent as May 2015, there was a news article stating him as the actual director of the center. Li Jianhua is another interesting figure. He's out of Shanghai Jiaotong University. And has worked on the S219 project, which is a little bit more related to the Golden Shield project, but he also had another one that was for the Network Media Regulatory and Information System. That actually warranted a visit by the premier at the time. So once again, the research that these guys were doing, heavy amount of importance was placed on it by the leading Communist Party figures at the time. He also has some really interesting connections to 61398, which everyone knows is APT1 or Comment Panda, depending on which naming scheme you follow. And has done quite a bit of work on the several confidential projects. That's what the XXX is up there for. As far as we know, he hasn't done porn or anything. So he's usually on their resumes. A lot of times there's quite a few of these XXX awards, and that basically means that they've worked on quite a few confidential projects. So all of these guys are still, once again, on very senior level groups and continue to do that today.
All right. Now that Adam provided us with some background about the history of the Great Firewall, we're going to get back to the Great Cannon and look at how it actually works and what it did. So the idea behind the Great Cannon is that it injects malicious JavaScript into benign web connections. So popular web services in China like Baidu and Baidu Ads were targeted. And their JavaScript was replaced with some piece of malicious JavaScript, which in turn then used the browser to make requests to these target sites like GitHub and CloudFront, and thereby overwhelming these target sites. So you can imagine like a huge search engine, the biggest search engine in China, you can imagine how many visitors it gets. And if each of these visitors in turn then posts requests to another website frequently, this will quickly generate a lot of, like we saw, 2.6 billion per hour HTTP GET requests. And so this over here is kind of the timeline of when these injections took place, courtesy of Google Safe Browsing, who were able to follow that, but only in hindsight, one has to say. That's an important part. So we can see that it started out with the testing phase with a low number of injections, and then it actually escalated when the actual attack started, and that coincides with the timeline we saw earlier. So what the Great Cannon does, and that's how it differs from the Great Firewall, once again, this picture is courtesy of the Great Citizen Lab report, is it's a full man in the middle. So it's not an on-path, but an in-path system, meaning it can actually interdict the traffic reaching the intended web server like Baidu.com and can replace the response with arbitrary content. And that's what it did. It didn't act on every packet, so it had some selection mechanism. So not every user was targeted, and that's also different from the Great Firewall. Citizen Lab tried to locate the attacker. They wrote a tool which would do basically a trace route and then see where the Great Cannon would be active. And they limited the Great Cannon activity to 2 autonomous systems, both of which are within China Unicom infrastructure. The earliest hop basically that did the injection was 2 IPv4 hops behind after entry into China, which is not saying a whole lot because China obviously also employs IPv6 tunneling internally, so it doesn't really tell you that much. Interestingly enough, the tool by Citizen Lab also looked for activity by the Great Firewall, and if you run it, you can actually see that the hops where the Great Cannon and the Great Firewall are active are the exact same ones. The Great Cannon also shares some characteristics, some side channels with the Great Firewall that are not that cannot be found in other commercial tools. So Citizen Lab concluded that there was at least some overlap in how these tools were engineered. But still, it's important to keep in mind that these are completely separate and distinct systems which have different capabilities and different targets. So about the exact location, people tend to obsess over that, but ultimately it doesn't really matter. At least that's the way we see it. Some further facts. As I said, it injects malicious JavaScript. Currently, it targets only by destination IP address, meaning the web server you're trying to reach. But it could just as well target by source IP address, meaning the client doing the request. It does probabilistic targeting. Not every user is targeted. It has some weird behavior, meaning it will actually act on connections which are not completely built up, like TCP connections, which weren't initiated with a SYN packet. It will also act on incorrect HTTP requests, and all of these artifacts can then be used to detect that there's something strange going on, and that's the way this tool by Citizen Lab actually works. And probably the most important part that people sometimes miss is that it only targeted international users. So only international users going to the Chinese website like Baidu would get targeted. Obviously, that it's mostly Chinese-speaking people, like in Taiwan, Hong Kong, or even in the US. But that means that the requests that are being sent as a result of this malicious JavaScript come from outside of China. So if you're GitHub, you cannot simply say, oh, I'm just going to block the traffic originating from China because the traffic is coming from every user worldwide. And that's really important to keep in mind. So one thing we did that not a whole lot of other people did was take a closer look at the actual JavaScript, at the actual payload that they injected to the connections. And it's a relatively short code snippet. I put it here. You can find it online as well. And even if you don't write JavaScript, you can probably read that piece of code. So you can see that it tries to use some libraries, some convenience library. It has a few function definitions. It has an array of targets, this URL array, and that's actually the list of targets it wants to do requests against. So this one is CloudFront. And it has some functions for sending. And then it has an additional function, which is the actual get function. And that's, if you know JavaScript, if you know jQuery, that's just a basic like do an HTTP get on that URL. And you can see that they have a handler which says basically after the request is done, set a timeout, set a timer, so that the next request will get out in like 10 seconds or something like that. And that's the whole JavaScript. And this was actually, it wasn't obfuscated. So this is the way it was delivered to the users. It's very readable, it's very short, it's very simple. So you might say, why talk about it? But even this short piece of code contains some interesting things, at least we think so. Which give us some hints on how this might have been written. So it has some incoherent variable naming, like it uses camel case and snake case, which is not something that a programmer usually mixes up. It has some needless and buggy functions. It also shows that the author of the code might not have been familiar with JavaScript that much. It has some leftover code fragments, which look like there was something there before, but they got rid of some functionality and left some code in, like this count variable. It relies on jQuery, which is generally really noisy and easy to detect. And it actually improved during the campaign. So during the campaign, they apparently realized that they can pack the JavaScript so it looks a little bit obfuscated and it's not as readable as this. And a later version of the injections used that, which is funny. So the bottom line, and I'm not trying to bash the people here, but the bottom line is this is a little bit sloppy code, which is strange if you're trying to unveil your really cool, great Canon tool and attack users to write this piece of sloppy JavaScript code. Also, it's copy-paste code, so I mentioned the variable naming. That's really strange. That led me to believe they copied and pasted code from somewhere. And if you actually go on search engines, this is Baidu, but you can do the same thing on Google and search for terms like jQuery ping, which means just get something from a website periodically. You come up with this code snippet as the first hit, basically, and that contains the exact same variable names that have been observed in the payload. So yeah, that's a little bit of copy-paste programming. Right, so it's only JavaScript, right? Why is it relevant? So first of all, it's obviously not realistic to use the web without JavaScript anymore, so turning that off is not an option. And it's also not easy to say what malicious JavaScript is. I mean, is that malicious behavior that we saw in this piece of payload? It's just doing HTTP GET request. That's what these libraries and methods are there for. So how would you tell that that's malicious? Still, there's some individual risks to having this kind of injection. So this is basically what we in the industry call a strategic web compromise, where you are able to compromise a high-volume, high-value website and then target the users as they come by, and then you can use that to target individual users. And there are actually frameworks for that, malicious as well as academic. Also, if we remember some earlier leaks this year, drive-by exploitation of various technologies like Flash and Java is still a topic, and they might have just as well injected some Flash zero-day instead of some JavaScript. And keep in mind that this system is a lot simpler for them to use than something that other Western governments are using to do that kind of stuff. So they have a full man in the middle. They don't need a complicated setup to be able to target specific users. They don't need distributed infrastructure. They can just sit there at their central locations and inject whatever they want. And also, which is interesting, they are pure JavaScript attack vectors. So for example, you could use WebRTC to get the IP, the real IP of the host, which is important for Tor users. And you can do the whole bunch of other stuff you can usually do with JavaScript. So a good reference for that would be the talk 2 years ago at Black Hat, which was called the Million Browser Botnet, which talked about all the different ways that you can abuse JavaScript to do something in the user's browser. And this is basically the same thing, only that it is a multi-million browser botnet that the government can turn on with a flick of a switch. So let's talk about some countermeasures. These fall into different categories. The most important ones are the one in the top line, I'd say. So this is kind of the prevention, but we'll also talk about how to look out for that kind of activity. HTTPS is the first one. So HTTPS would have prevented that problem because they wouldn't have been able to inject malicious JavaScript into an encrypted connection to the web server. So why is that still an issue in 2015? And we looked at the most popular websites in China based on the Alexa list. And you can see them right here. And we looked at the state of their HTTPS adoption. So the left column, the leftmost column says whether they actually offer HTTPS, which is for most websites not even the case. The next one says whether they offer HTTPS but have some mixed content, which could be exploited. The third column tells you whether the plain website, the plain version of the website, will try to redirect you to the HTTPS website. And the last column, you have to purchase something. The last column tells you whether the website uses HSTS, which is HTTP Strict Transport Security, which basically tells the browser, next time you can buy, only use HTTPS. Never try to reach me using plain HTTP again. And so it looks a little bit different. It looks a little bit different if we look at Western websites. And I think a big reason for that was obviously the revelations by Ed Snowden. Some other facts about HTTPS in China. So companies might say there are few incentives for us to adopt it, Chinese companies. That's obviously a convenient public reason. They might be pressured to not adopt it. Baidu, which is the biggest search engine in China, will actually not index your site if it's running only on HTTPS. So you have to offer it in HTTP if you want to be on the search engine. And this HSTS list, which is built into browsers, which tells browsers only visit these websites using HTTPS, only includes 6 very small Chinese websites as out of 1,300 in total. Also, there's currently no domestic Chinese root certificate authority. It was removed after a security incident, but it will likely be reinstated, the CNIC, that is. So what can you as an organization do, especially if you have your web server somewhere in China? Yeah, the answer is HTTPS. It has never been easier to deploy. The performance impact is minimal nowadays. And there's even a free and automatic certificate authority coming in September of this year, which will make it really easy to set it up even for non-technical folks. HTTP 2.0, which is also being rolled out as we speak, actually requires TLS. So if you want to use that, or if your developers want to use that, you're going to need it anyway. Please consider using HSTS, and please consider preloading it into the browser. And there's even something called the public key pinning extension, which tells the browser not only to use just HTTPS, but only use a specific public key. So even if, in the worst case, what some people try to make up, even if there's a rogue CA somewhere in your browser chain, and that rogue CA starts doing TLS man in the middle successfully because it's in the CA store, using public key pinning, you would be able to prevent that and also report it, which is really important. So saying TLS doesn't matter because there might be a rogue CA is no longer true. So the bottom line, the threat can be reduced, and there's no reason not to use TLS anymore. So next topic would be monitoring. How could you possibly watch out for an attack like this? And the first thing to keep in mind is static monitoring, like downloading websites and then doing diffs or whatever. That's not going to cut it at all. So you need some kind of monitoring of the dynamic behavior of a website. And to do that, you have to build up the document object model and actually execute the JavaScript to get the behavior. There are different approaches, none of which fit my bill. So what I really wanted was something like this, and you might be familiar with that. That's the Chrome debugger. I want to know what kind of requests have been made, what kind of resources have been downloaded. I want to know about JavaScript errors. I want to know about output or stuff like the alert box. And so, yeah, I want all of these things listed here, details on the request and so on. So basically, I want an instrumented web browser, right? And I looked at this kind of screenshot, and then it occurred to me, well, the Google Chrome Inspector, which is a development tool, actually uses a public API, a JSON API, to interact with the Chrome browser in a debug mode. And you can use that same API to get all of the information that's available in the Chrome Inspector to do exactly that. So you have a really cool way to have a believable browser that you can use in an automated fashion to do this kind of monitoring. And then to set it up, you obviously have to set it up to browse different websites frequently. You have to geographically distribute it across different IPs and continents. And then you have to think about how you want to annotate that data, what kind of additional information you want to put into that data. Do you want to create a call graph? Do you want to do GeoIP or autonomous systems lookup? Because the bottom line is, what do you monitor for? What's malicious behavior? And when do you want to be alerted? And that's, I think, a really tricky question to get that just right. So again, the bottom line is, if you're considering doing monitoring on your own website, you're better off just employing transport security.
Okay, taking a look a little bit behind the curtain as to who might actually be responsible for this. Obviously, as Johannes talked about earlier, locating the actual source of it is kind of irrelevant for several reasons, but we know that basically it came from the China Backbone Network, and that there are very few organizations that have access to that and can control that. When we talk about possible contributors, it's important to note that since coming into power, President Xi Jinping has done quite a few different reforms. This is making himself, as he consolidates power, he's been making himself the head of multiple information leading groups. One of them has been to take a better control of the PLA and the military. The other has been establishing something like the cybersecurity and informatization leading group. So he actually chairs that and is, along with Lu Wei, who heads the cyber administration of China. Like I said, he's kind of the cyber czar of China. Those guys are basically making all the decisions at the top. And Lu Wei in particular is a very effective politician. Attending a conference with him in, let's see, that was DC of this last year. Super charming guy. There were FBI, CIA, NSA guys in the room, and he was cracking jokes with all of them. Really good politician. But he definitely knows what he's doing. He's no dummy when it comes to this stuff. And he also runs the State Internet Info Office, which basically handles censorship and, we believe, the Great Firewall of China. So they have, as you can see, those tenuous connections with the ISPs, as well as the Ministry of Public Security. So that connection is kind of more of what we were talking about when we say like the Golden Shield project. So the censorship plays directly into the MPS, which basically enforces the censorship. So the consolidation, because they've been doing all this consolidation, squarely places them at the top of the decision-making process. And in addition, there are, on these working groups, quite a few senior figures that played an influential role in the creation of the Great Firewall. We talked about some of them earlier. So there's quite a bit of a mix between these civilian and military groups. This is important because the collaboration there has been talked about before, but there are very few organizations which are authorized to kind of carry out offensive cyber operations against national targets. The PLA is one. We've obviously talked about that quite a bit with our own CrowdStrike reporting. MSS, which is kind of the Chinese version of CIA, and of course the MPS. So When we're talking about these groups working together, that's really important to highlight is that some of these guys had a very influential role from the start and are probably still involved in some of that stuff. For example, one of these working groups, this is an 863 informatization working group, actually features both Li Jianhua, who actually heads the organization, and Fang Binqing. So both of these guys that, like I said, had a pretty influential role in the founding of the Great Firewall are on this council. And the other ones that are highlighted on there are someone from the First Bureau of the 3PLA, which of course conducts SIGINT operations, as well as somebody from the MSS 13th Bureau, which does science and technology. So when we're talking about who could possibly be behind this, you know, there's definitely some groups that come to mind. There we've got a nice picture, Fang Binqing and Li Jianhua at a 973 conference. 863 and 973, we have a lot of reporting on that as well. Definitely see us for that if you'd like more information, but they kind of serve as a roadmap to what China wants to accomplish and close the technological gap between itself and the West. So what happens next? This is probably the big question on everyone's mind. We see this as kind of China releasing this, even though it was kind of sloppy code. We were a little confused by that as well. But this is kind of their moment to say, like, this is my boomstick. We can use this. You know, we're pushing the notion of cyber sovereignty beyond our own borders. You know, Great Firewall was to keep out invaders, keep things centralized and harmonious is the word that they tend to use the most. And the Great Cannon is expanding that outwards. Will we see it being used in the exact same way? Probably not. There are a lot of improvements that could be made to the attack, kind of a best case, worst case scenario, depending on how you look at it. The big question, of course, is will there be blowback? You know, the official response from the US government at first was basically just an inquest which to the Chinese government, which is kind of like asking the kid with cookie crumbs all over his face, like, did you have a cookie? Did you? So it'll be interesting to see if they use it again, what will happen from that standpoint and from a political fallout standpoint. One of the things that did happen fairly recently is the Obama administration made it so that they could basically sanction countries that carry out cyber operations. So that could be possibly something we'd see in the future. So it was pretty lucky in the fact that this was an early and unsophisticated attack. It was evolving and changing even as it was ongoing. But overall, you know, GitHub was still standing at the end of the day, and it could have been a lot worse. When we talk about targeted attacks, it gets a lot more serious. So we expect to see that play into the Great Cannon's usage in the future. So they'll improve a lot of these things, possibly using you know, more obfuscated code, as well as, you know, persistent SWC attacks. It'll also be interesting to see if the CNNIC root authority gets approved again in browsers, because that will enable another method of potential infection and could bring a whole nother side to that as well, since browsers would automatically be trusting that. Like I said, currently they have been rejected from that after some controversy, literally around the exact same time as the Great Cannon attacks. But we do expect that they will be reinstated at some point. Let's see. So who might be hit next if we do see an attack again? Some of the big ones coming up that China is very interested in is the Taiwanese presidential election, where currently the person that's in the lead so far is fairly anti-Beijing. And so that's something they're a little bit worried about. Whether we would see it actually bring down an election website, that'd be pretty ballsy. But it's definitely something that they're interested in. And we talk about potential targets. That's for sure one of them. The issue with Hong Kong and the open referendums for their elections, that's still ongoing. That could be another one. And of course, at CrowdStrike, we've seen quite a bit of activity related to the South China Sea and Vietnam and any of the other territorial disputes that they've got going on there. And then we could also see now targeted attacks, as we said, against domestic entities as well. So Dalai Lama and Tibetan movements, as well as the Uyghurs out in Western China. And that is going to about do it for us.
Yeah.
So thank you very much. Definitely recommend checking these guys out as well. And we did bring our own cannon.
So while we try not to hit anyone with this one, if you guys have questions, please move up to the mics. Otherwise, you can always find us after the talk. We'll hang around for a while. That looks really dangerous, by the way, but. Okay. No question. Yeah. So the question was whether the use of HTTPS would have prevented that, and the answer is yes. So they wouldn't have been able to inject content into the connection that easily if they use HTTPS. As we said, they might use different techniques like employing their own root CA, but that would be really dangerous and easy to detect. So that's the main takeaway, that if your website is in China or if it's outside of China, or in general, if you care about your users not being injected by anyone in the middle, use HTTPS. And the second question about whether Chinese users would be able to still see the website. So this was an attack on web servers. It's really loud, guys. It was an attack on web servers which are located in China, and it was targeting the visitors who came from outside of China. So the Chinese, the domestic users in China, they weren't even affected by that. For them, it's completely irrelevant, and they don't actually. I think Baidu by now uses HTTPS by default, but only for domestic users in China, which is kind of ironic. Yeah, I think so. I read that, I think a few days ago.
I've got a question over here. So I was wondering a little more about the WebRTC and what it's able to actually get around. I know you mentioned Tor, but is it also able to get past VPNs in some cases, or what all can it do?
Yeah, so basically, there's some demo code on the web if you Google like WebRTC IP leak or something. But if you're running Tor on the same computer, on the same machine, so you're not running it in different virtual machines, then this kind of info leak is able to get your real IP. And that's actually been used in the wild. I think it was even the New York Times, which did that to identify the IP of the users. And that's really dangerous because a lot of the people using Tor, especially in connection with China, are trying to circumvent, for example, the firewall or any kind of censorship. And those are not the most technology proficient users, so it's really relevant for them.
And just out of curiosity, I'm guessing it bypasses NoScript in some form, or is that a protection mechanism that works?
No, you're right. If you have NoScript and you really don't execute any JavaScript at all, then you're safe from that kind of attack. But as I said, it's not really realistic if you want to have any kind of browsing experience, right?
Right, very good. All right, well, thank you.
I have a question. Do you know what's being done to sort of prevent this cross-origin attack that they were able to do with JavaScript?
What being done by whom?
By, I don't know, any standards body or someone to help, you know.
So as I said, that's not malicious behavior. That's not like you could say. It's not something. It's something that you want. It's a feature. If GitHub was hosting some piece of JavaScript and you wanted that on your website because it's a library and you want to use that, obviously you have to make a request to GitHub, right? So they can't prevent that request from happening. Or did I misunderstand the question?
No, I think you understood the question. I guess it's just that's the problem with this whole thing. Thank you.
What's the last one? It doesn't say so. It just says in the Baidu fact, like FAQ, we don't index HTTPS websites. And about them not adopting HTTPS, I tried to reach out to all of these websites to get some kind of reply on why they're not adopting it or why they're not making it default. I didn't get any replies on that. As I said, I think it's convenient to say, it's economic or it would be too costly or complicated to set up HTTPS, when at the same time they might be pressured not to make it the default. That's the way it could be.
So, and you also have to remember too that most of these big internet companies in China have a very close relationship with the government. And so the important thing to remember is that most of these are all publicly traded companies. So if they are pushed hard enough, they do have stakeholders. So they have before kind of gone against the Chinese government, although with limited success. So that doesn't always work. But it'd be interesting to see the more that their stakeholders express that to see what would actually happen.
Okay, another question back there.
Yeah, just real quick, could I see your reference slide again?
This one?
Yes, thank you.
Yeah, so definitely suggest reading those. There's quite a bit more, which, like I said, we can feel free to come up and talk to us and grab emails, and we'll provide you with even more.
Thank
Okay. Cool. Any others?
Okay, you can meet us here or in front of the ballroom for the next 20 minutes or something.
Yeah. Great.
And thanks for attending.
Yeah, thank you guys.